Hi, this is your host Swapnil Bharti and welcome to Let's Talk About Cloud. And today we have with us once again Rob Hirschfeld, CEO and co-founder of RackN. And we are running a series here, and this is the first episode of that series, which is about ways to sell infrastructure as code to your boss. Rob, we have talked about infrastructure as code for so many times, but just lay the foundation. Quickly tell me, how would you define infrastructure as code and why it matters?
Infrastructure as code is hugely important. It really defines a technology trend in infrastructure automation where we're treating it much more like we treat traditional types of code, which means source code control, build processes, continuous integration, infrastructure pipelines. All of these pieces that we're used to doing from a development perspective, we're applying to infrastructure. And that's how I think of infrastructure as code for technologists. But for your boss and for an executive, which is really who we're trying to target here, infrastructure as code says, why isn't my DevOps or my SRE team or my sysadmin team as predictable as my development team? And that's ultimately how it needs to be framed. Infrastructure as code is this aspiration that we're going to automate things as well as we write code and development with the same quality and consistency and predictability and modularity and reuse, because nobody thinks about writing code from scratch, right? You pull in libraries, and we don't automate that way yet.
When we are talking about infrastructure, what exactly are we talking about in a hybrid multi-cloud world? Because you can be on-prem, you can be on public cloud, you can be mixing. So what exactly is infrastructure in the cloud native world?
I love this question. It's all of it. And this is one of the challenges that we see that makes infrastructure as code so hard and so frustrating for executives in this space is they have every one of those teams, each cloud, each type of infrastructure is coming up and saying, I need this tool to do infrastructure as code. And they're all different. And so it would be as if, every development team in an organization decided they had to use a different language. And that's not how, enterprises get economies of scale. It's not how they get efficiencies. And so when we look at infrastructure as code, it really is about how do we pull together all of this infrastructure into more common ways, right? How do we get better ROI from the infrastructure? And one of the ways we do that is by not reinventing the wheel every time we come to a new cloud or a new type of server or a new location.
Now, if we are trying to build a strategy around infrastructure as code, we also need to understand, or actually at least define, what are our expectations? What do we expect from our infrastructure? Then we can talk about these 6 points that you highlight.
Infrastructure is one of those funny things. It should just be normal. It should just be expected. And that's what businesses really want. They want things that don't interrupt business function. They want predictable. They want standard. They want to know that they have supply chain security, right? That's what we're trying to achieve with infrastructure as code and infrastructure automation in general. And I think of it like building codes, right? When somebody goes to build a house, they know they don't think, oh, what size wood should I use? What dimensions should it have? How high should my ceilings be? What type, how should I design my outlets? All that stuff is already standard. It just fits together. And there's codes that govern the way to do it safely. We put studs a certain amount apart in a house because everybody does that. It's a standard and it creates safety and resilience. And we need the same thing for our digital infrastructures. We need standards and modules and practices that everybody understands and expects. And as we get towards that, it dramatically accelerates how we can build and manage infrastructure. It also makes it easier to hire people, and it makes it easier to secure it, which everybody's, that should be keeping you awake at night.
What are these 6 points and how to approach them one after other?
So when we look at infrastructure as code, and most expect specifically how an executive looks at infrastructure as code, because we don't want to just sell, hey, this is cool tech, or this makes my job easier. Those aren't the right selling points. We have to look at something more. And so we have identified 6 key things that really make a difference. 5 of them are improvements, right? Improving visibility, improving compliance, improving speed, improving predictability, and improving collaboration. Those are key things that are all business values. And the 5th one is actually reducing the bus factor, which means what happens if you lose a critical person or in some a critical resource. But a lot of this is about collaboration. And it's easy to overlook, how much all of this is about collaboration and the teams that are supporting the infrastructure, making them more effective.
Let's deep dive into improving visibility. Of course, you talked about the importance of it, but what are some of the ways they can improve it? Are there tools or is it a cultural thing?
It's going to be a combination of both in every case. One of the biggest frustrations for an executive when we hear from our customers that they just don't know what's going on. If somebody asks them a question about what's deployed or how it's deployed or is the deployment working, they really don't get good answers back from that perspective. And so a key thing with infrastructure as code is not just can I run a process, but can I actually show that the process is working. That ability to see what's going on and show it, or show who changed it and what the audit log was and what the controls were, those are important things for an executive to feel confident in the infrastructure that their business is relying on.
Now, let's talk about compliance. Of course, we all know the importance of compliance, and I think bosses really do worry about that a lot.
Yeah, without a doubt. We see this, we deal with banking customers and compliance is a legal requirement for them. But this isn't just about, am I following the laws? A lot of times, am I following the corporate standards? Do I have, is the security team able to say, this is the pattern you should use, and then ensure that it was done? When we look at compliance, it really is about knowing that the things that you think you're going to do, you're doing, and you're following the rules that you set for yourself. And one of the things that's amazing to me in automation today is you can have 10 teams and 15 ways of automating the work that those teams do. And making a change to any one part or any one team is very difficult to ripple through. So if you wanted to have your teams following a certain process, incredibly hard to make that work. Infrastructure as code is a way of saying, you know what, we can actually share automation pieces or we can share process components, which brings the whole organization into compliance, which then allows you to have a lot more confidence as an executive that people are doing the right things. It's really scary to think of a whole bunch of teams, doing whatever they wanted, and you're going to be awake at night wondering if one team, left a system unsecured because they didn't follow the process, and you have no way of knowing that it happened or enforcing that they even couldn't do that. Compliance is a big deal.
I want to quickly talk about compliance as well, where it goes beyond just those legal frameworks where you have to do things in the legal parameter depending on who you're serving. I also want to talk about the compliance of code itself. Are you pulling images that might violate some licenses that you are using in some other code? Is the version, it could be Kubernetes or whatever it is you are using, can you move between one vendor to the vendor? So can you also explain this aspect of compliance as well?
I'm glad you're asking. It is a really important question. Legal compliance is important and you get in trouble for violating it. But even well before that, a lot of companies know what they should be doing. They have rules, they have governance, they have targets, right? They know what they should be doing, but they don't have any way to ensure that it's happening or actually make it easy for people to adopt what should be happening. And so, compliance is as simple as my team thinks it should be doing the process this way and does it that way and knows they do it that way. And that could be applying patches to an operating system. It could be being multi-vendor like you were describing so that they have a backup. It could just be, I need to set, this firewall setting on all the servers I deploy, but somebody turned it off because it was breaking their development builds, and that made it all the way into production. Compliance is the root of most failures, or lack of compliance is the root of most failures. And we know that we should be doing it. We just don't have the tools and the processes that make it easy to enforce all the way through.
Now, the next one is delivery speed. Of course, nobody can contest that. We all want to move faster.
We all want to move faster.
Yeah, I mean, it's expected, but how to achieve it?
This is one of those classics with agile and lean manufacturing where doing things in smaller steps, decomposing big problems, actually improves the speed that it's happening. This is one of the ones, I'll give you an example from RackN that I found really remarkable. So in building our universal workflow process, our engineers put every possible step in that universal process, which means we do a whole bunch of work that you don't need to do in every single part of the process. And most of them just no op and they keep going. But the idea that you were doing the same steps every single time all over the place meant that the whole system actually went faster, because if you needed to turn on something or change it, you already had the steps in place. And so our ability to deliver working product accelerated, even though we were doing more, or the computers were doing more work in that sequence. So there's a little bit of a paradox in here, where a lot of times that what might feel slower because you're taking smaller steps, or you're breaking things into bigger pieces, or you're ensuring a uniform process, ultimately makes things go faster because you can rely on it more. Just like a development example is building unit tests, and system tests enables developers to make small changes because they can count on the systems catching, if that change broke things that they weren't thinking about. It's the same type of thing with infrastructure as code. As you build those processes and protections into the system, the speed of the whole system accelerates.
Excellent. Yeah. Now the next point is predictability. Now that this, I think, depending on who you ask, they might define it in a different way. So I do want to hear, how would you define predictability, and then we'll talk about how to achieve it.
Yeah, predictability is a really important thing. It's a little bit different than what a lot of people confuse it for, which is accuracy. Predictability says that when you aim at a target, that you consistently hit the same place in the target. You don't always get a bullseye. And so the idea with predictability, and that's really important for infrastructure, is that when you go to run an infrastructure process, you should be very confident that it will run all the way through to the end, right? And the more confident you are that have automated processes that work reliably, that you can count on happening, then you lean into that automation and it actually unlocks other capabilities. So one of the things that we see for RackN, we've gotten so predictable with a bare metal RAID and BIOS configuration patch that now our customers apply those processes on a monthly or even weekly basis, and they can run their systems through that process much more regularly, even if it doesn't take any action, because they're very confident that the attempt of applying it is going to have a repeatable result. That's just in one example. The more predictable your outcomes are, the more you can rely on them, the more you can move into a more dynamic and agile infrastructure, which is exactly what we saw with code building an infrastructure. Right? If we run an automated process that builds our code and deploys it, that allows us to deploy every minute, every hour, every check-in. That type of predictable, I made a change, it got into production, allowed us to do that acceleration. And infrastructure as code needs to have the same type of predictability, or it really doesn't make any difference at all. You won't rely on the systems.
So if we just look at predictability, of course, everything that you explained is great. What I was also thinking about is that predictability, I also want to predict, if something goes wrong, that I do know that everything will come back. And that's where I do know a lot of executives, or C-level, they don't like the term chaos engineering. That's why we use the terms reliability, resiliency. How much role does that play to ensure predictability? Because there are some practices that you follow, you break things, not in production like that. It's not actually chaotic, it's very structured and organized, but you just see how reliable your systems are. So does that play any role in ensuring predictability?
Oh, it's a huge component, right? You can't have resilient systems if you can't predict how they're going to recover or reset or be based, or even disaster recovery, bringing up a whole backup site or things like that. This is why it's such an important thing. And I think you're right. Resilience should be a component for infrastructure as code also. But you can't build any of that if when you run a script, you're not confident that it's going to work. And that's been a key underpinning of how all these things have to fit together. Because if you don't think I'm going to push this button and it's going to give me a successful result, or it's going to fail in a way that I can recover from, both are okay, then you can't build resilient systems around it. And that's a very important thing. In my experience, The executives here they're like, you push a button and you don't get the same result. I was at a big meeting with a whole bunch of bank executives, and they were starting to talk about, using automation to do a whole bunch of AI and analytics and advanced load shifting and things like that. And I stopped them. I said, most of our customers can't even be confident that when they say rebuild a server, that it rebuilds, that they have a 20 or 30% dropout rate from that process. And it started to become, a little bit of a heated discussion, and other executives pulled him aside and said, wait a second, he's right. We're not confident that we can rebuild our systems when we need to. Just get that fixed, make it reliable, and we'll build everything else on top of it. And I think it's a huge underpinning that when you're building automation, you should be really confident that it's going to work, or everything's going to fall apart.
Now, the next point is improved collaboration. Once again, collaboration is another topic which can be seen in a different way. It could be collaboration among internal teams. As much as we say that we have broken old silos, there are still silos, and that collaboration could also mean with external developers or open source communities. So first of all, what do you mean by improving collaboration here, and then how to improve it?
I like to go back to the developer analogy for collaboration, right? When people are writing code, they use libraries that already exist. It's very rare that a developer, should be never, starts from scratch and builds something that already exists. The whole point of development and development tools and libraries is that you get reuse. And that means you can collaborate. If your teams are working in the same language, then they can reuse the same libraries. You can have officially blessed things. You can have standard ways to do things. You can pick up somebody else's code and reuse it. I actually believe that collaboration in infrastructure as code should go way beyond that. Because when I look at the automation industry, the state of automation in the industry, it really doesn't have a very high degree of reuse. People aren't saying, oh, this plan worked for me, I can reuse it. And then importantly, if somebody else improves it, get the improvements back. That's the benefit of collaboration and development, is that when you make an improvement in how something works, other people get the benefit of that. And so we don't see that yet in automation, and we desperately need to. So infrastructure as code without the idea that I'm going to reuse and share and decompose modules and allow people's skills to translate team to team, so that if somebody transfers to another team or you hire somebody, all of a sudden they're relearning all of these custom things that you built. That's not how development works. It's not how we're going to grow this industry. We need to make it so that when people start doing work on infrastructure, that they get to be, they can walk in and say, okay, I already know how this works. I'm just looking at the little pieces that we've added for our business, the things that make us unique. And that's transformative when that happens, because all of a sudden we stop maintaining a whole bunch of bespoke custom logic and we start focusing on the business value pieces. And that's executive language right there, is letting your time move up stack from recreating the wheel. And you and I've talked many times about the idea that people are writing their own BIOS and firmware management pieces, silly, or cloud interface pieces, or even OS management, right? A lot of this stuff there's standard tools for. But those tools haven't been designed to help and enable collaboration or require collaboration. And so we still have silos. The next phase here is to really break down those silos.
And the next point is in your list is reduced buzz factor. You alluded to explain what it is, but I want to define it.
So the bus factor is the idea that somebody would get hit by a bus and you would lose that team member, and what would you do in that case? The idea, hopefully that doesn't happen, but emergencies and unpredictable things happen. People change jobs, and you need to be prepared for that. So anytime you're maintaining systems, I don't care if it's infrastructure systems, code systems, or business systems that only have a single or a small number of people who have authority in that, you've created significant business risk. And we sort of walked away from that. All these custom designed automation, or a silo where only one team does something very different than another team, all those factors mean that you could have a situation where nobody knows how to maintain the system, or expand it, or change it, or re-provision it. From an executive's point of view, that's a significant risk. And the fact that you couldn't have somebody come in and quickly understand what happened, or take over control of it when they needed to. Those are really significant problems. The reason why that's last here is that if you can't do all of the other pieces, then it's really impossible to have people be able to change in and out on these teams. But at the end of the day, one of the simplest ways to sell something to an executive is to turn around and say, see that person? In the Phoenix Project, Gene Kim did a really good job of articulating this through the character Brent, who was the only person who knew how to fix all sorts of problems and became the bottleneck for the organization. And so, there's definitely the risk that, a key person would not be available or go away or quit. There's also the problem that those key people become bottlenecks in your ability to run the infrastructure. And so if you can look at somebody and say, we'd be in a lot of trouble if that person wasn't there or wasn't available or got sick or quit, then your organization as a whole is at risk. And recovering from somebody like that can really grind everything else to a halt, or it could be reducing your organization's ability to move quickly in general, and it might be holding you back in very significant ways. So these are very tangible problems that, in executive speak, they can relate to. They can understand the personnel risk or the throughput being, ability being blocked. And as we know, a lot of times operation teams are the bottlenecks. They get the work late. They have to, make things happen. They can't change the code. They have to deal with the situation as is. And the more you can resolve those types of problems for an infrastructure team, the faster the organization is going to go and the less risk they're going to have to face.
Rob, thank you so much again for taking time out. And I'm actually excited about this series. This is the first episode. We'll be looking forward to the next episode. But thanks for sharing these 6, ways to kind of sell infrastructure as code to your boss. But actually, the insights they go beyond just a specific target audience. It's also very helpful for a lot of people to understand this. And there are a lot of people in the community, middle managers or higher tiers, they don't understand these concepts. So it's helped them as well to understand these points. So thanks for sharing them. And I look forward to a next episode. Thank you.
Thank you. Appreciate the time.